When an alcohol is added to an aldehyde in the presence of an acid catalyst, the product is called a hemiacetal. The hemiacetal has a hydroxyl group and an alkoxy group. So basically, an alcohol-like group and an ether-like group attached to what was the carbonyl carbon, or the carbon in the carbonyl group. Okay, so it looks like this. Okay, so here you have the aldehyde right here. And so again, in the presence of an acid catalyst, the alcohol is able to attach to the carbonyl group. You have the hydrogen, so this hydrogen is going to attach to the oxygen that was double bonded to the carbon. So it looks like this now, the OH group. And then you have the OR group being attached to the carbonyl carbon. So now we have the alcohol and the ether to form the hemiacetal. In general, aldehydes are more reactive than ketones because the carbonyl carbon is more positive in the aldehyde. So the reaction, if you see right here, the arrows, so this is an equilibrium symbol. So that means the reaction goes in both directions. So we can take the the aldehyde plus the alcohol to form the hemiacetal, and then it goes back. And the hemiacetal can go back to the aldehyde and the alcohol. Hemiacetals are not stable, and so because they're not stable, they can't be isolated, but a cyclic hemiacetal can be. So it's formed when the carbonyl group and the OH group are in the same molecule, and you can see in this picture, so this OH group bonds with the carbon and the carbonyl group, and it forms that cyclic ring. So again, the hemiacetal is not stable, but when it's in the cyclic form, it is stable. And most simple sugars exist in the cyclic hemiacetal. So this is actually glucose, and this is what glucose looks like. So again, it's stable in that form. So I'm not going to have you draw any of these. We're going to focus on just the reaction between the aldehyde and the alcohol to form the hemiacetal. And then we're also going to, like we do in the next slide here, react again with the alcohol to form the acetal. So you won't have to worry about actually drawing those rings. So hemiacetals are generally unstable and will react with the second molecule of the alcohol. So right here we have this first alcohol reacting to form the hemiacetal, and then the second alcohol reacting, and now we have the acetal. So the R chain, so you can just imagine, this is R and this is H because it is an aldehyde. So those aren't leaving, those are still there. But the alcohols are attached to this carbon that was in the carbonyl group. So here's both of where the alcohol's attached, and now they're ethers. So the same thing can happen if you have a ketone. So when an alcohol is added to a ketone, a hemiketal is formed. And a hemiketal is a compound with both an alcohol-like group and an ether-like group. So just like what we talked about with the hemiacetal, except this is a hemiketal because it started out as a ketone. So pretty much the exact same thing is happening but now with a ketone. So I accidentally, on this picture, meant to mark this out and put ketone, because that's what's shown in the picture, ketone plus the ethanol, whoops, and then the hemiketol. Oh boy, let's try that again. So mark those out on your notes. Sorry about that. So again, we have the same thing happening. So we have this hydrogen is going to attach to the oxygen in the carbonyl group, and then the rest of the alcohol will attach to the carbon in the carbonyl group. So they just kind of shift that CH3 down here, and that's fine. Or you could attach the alcohol down here. It doesn't really matter. So don't let that confuse it. That CH3, they just move down. Okay, so it's exactly the same as the hemiacetal, but now we're just beginning with a ketone rather than an aldehyde. So we can also form the ketol, just like we did with the acetal. So here, if we have some acid catalyst added to the reaction of an alcohol with a ketone, then we get the hemiketol, which we can see here, right? So here's the ketone, here's our alcohol, here's our acid catalyst, and we get the hemiketol. And then we can add, because remember, they're not stable. The hemiketol is not stable as well, and so it will react with another alcohol with the acid catalyst to produce the ketol. So both of those alcohols are attached to this carbonyl carbon. Okay, let's do some examples here. I do have one mistake on this slide. So this should be, this should be 2-butanone. I left my 2 out. So we're going to do these on, I'm going to switch over here to this. Okay, so the first one we have is propanol. So 1, 2, 3, so propane, but it's propanol, so remember with aldehydes we don't have to number where the carbonyl group is, because it's always on the first carbon. So we have propanol with methanol. So methanol is just CH3 OH. Okay, so now the hydrogen, this hydrogen is going to attach to the oxygen. Okay, and then the alcohol, the rest of the alcohol will attach to the carbon in the carbonyl group. Okay, so we're going to get, I'm going to switch, I'm going to switch to the condensed formula. So we have CH3, well, that doesn't really look like a 3. Let's try that again. CH3, CH2, and then C from the carbonyl, and then we have the O up here, and now hydrogen is with it. Okay, and you can put our H down here from the aldehyde, or you can put it just right next to it. And then our the rest of our alcohol attaches right here, OCH3, to make that ether-like group, the alkoxy. Okay, so that was number 1. Number 2, so again, we're doing 2-butanone. So 2-butanone is a ketone. Okay, and we're adding that with ethanol. Okay, So we have CH3, CH2, OH. Okay. So the hydrogen is going to go with, I'm going to write this in condensed formula again. The hydrogen is going with the oxygen. So we have OH. Okay, and you can continue out your chain to the right, or you can bring it down here. And either way works. So we have just 2 carbons left, so CH2, CH3. And then I'm going to put the rest of the alcohol group right here. So we have O, CH2, CH3. So this portion right here is going here. The hydrogen went with the O. The hydrogen looks weird. Okay. Okay. Let's do number 3. Okay, number 3, we have cyclopentanone. So it's a ring because it says cyclo. Pentane, we have 5. I'm going to put a ring of 5 here. And we know it's a ketone because it's cyclopentanone. So I'm just going to put my oxygen right here. Okay, we have that with propanol. So 1, 2. Okay. Okay, so then we draw a ring again. Okay, we have our OH here. And then we have, so this is going to attach to the carbonyl. Okay, so we're going to have O, might run out of room, CH2, CH2, and then CH3 on the end there. Sorry, I ran out of room. Okay, so that portion is right here. So O, CH2, CH2, CH3. Okay, and then number 4, we have ethanol. Okay, ethanol. We have CH3, COH, or acetaldehyde is the another name. Ethanol or acetaldehyde. And methanol. Okay. So then we have CH3, C, the OH. So we take away that double bond, add the hydrogen, and then I'm going to put my hydrogen down here and then add the ether group here. So O, CH3. Okay. Okay, and then we have 2-methylpropanol. Propanol. Okay, so okay, and then we have ethanol. So CH3, CH2, OH. I'm going to redraw this. Okay, and now instead of the carbonyl, or the double bond to the oxygen, we have OH. And then I'm just going to put the rest of the alcohol down here. We have O, CH2, and CH3. So again, the OH group and the ether-like group must be attached to the carbon that was in the carbonyl group. Okay, last thing. So we can continue on, which let me show you that real quick. We can continue on to form an acetal. So all we have to do that is just add another alcohol to our hemiacetal. Okay, so I'm going to redraw this here. So we have the OH, and we have the alcohol, or the ether group here. Okay, so if I add one more of the ethanol, then it's going to go where the hydroxyl group is. Okay, so let me redraw this here. So instead of the OH group here, now I'm going to have another ether group, another alkoxy group. So I just have two of these, exact same thing. So my OH group goes away, and now I have another ether-like group for my acetal. Okay, so that's all you have to do. Add one more of the alcohols to get the acetal or the ketol. So I'll do one more example with the ketol before we move on. So for example, we'll do this number 2. So the 2-butanone plus the ethanol. So the hemiketal we formed was CH3, C, OH, CH2, CH3, and then we had our ether group right here, O, CH2, CH3. Okay, so to get to the ketol, we add another, what do we have? Ethanol, CH3. Oof, that does not look like a 3. CH3, CH2, OH. Okay. So now that's going to go where the OH group is. Okay. Oh. So again, for the acetal and the ketol, you'll have 2 of the ether-like groups attached to the carbonyl carbon, or what was the carbonyl carbon. So OCH2, CH3 now. So you can always tell the difference between the, so again, this is a ketol. You can tell a difference between the ketol or the hemiketal or the acetal and the hemiacetal because that OH group is gone now, and now we have 2 of the ether-like groups attached to that carbon. Okay, we can also have the reversal taking place, so we can go from the acetal back to the hemiacetal or the aldehyde, and we have the ketol going back to the hemiketal or the ketone. So the reverse reaction does take place with the acid catalyst and water. So you can see that right here. Here's my water. Here's my acid catalyst. So basically, it just removes the ether groups. Okay, so you can see the OR goes back to the OH for the hemiacetal or the hemiketal. Okay, and then we do it again, and now we remove this ether-like group, and now we're back to our aldehyde or ketone over here. And so we'll do some examples here. It says, what aldehyde or ketone will form from the hydrolysis of the following acetal or ketol? Okay, so I'm going to redraw this ring here. Whoops, whoops. What happened? Let's try that again. Okay. So I'm going to redraw the ring. Okay. So the carbonyl, the ether groups have to be attached to what was the carbon in the carbonyl group. So that carbon in the carbonyl group is located right here. Oh, right there. Okay. So that means those will come off and we go back to just a double bond oxygen like that. So this was the ketone that formed this ketol. Okay, so we can do the same thing down here. Okay, so on this one, you know, our ether groups are here and here. So that means the carbonyl carbon was right here. Okay, so we're just going to have the CH3 and a hydrogen attached to our carbon in the carbonyl group. So we'll get oxygen, and then we'll have the CH3 on one side and hydrogen on another. So this is the aldehyde. Oops. And this was the acetal.